Hi, this is Brian Kim. I want to share with you case number 182 in the best way to do cataract surgery series. This is an average lens density, and you're going to see how I'm able to conquer intraoperative floppy iris syndrome, IFIS, with double chop and cross chop and mechanical fracturing techniques. So remember, when you're disassembling a lens and you're trying to grab pieces up, what do we normally do? We grab pieces with vacuum. And when you grab pieces with vacuum and you're using a lot of techniques that require vacuum, for example, impaling the lens piece when you chop, like we're taught with vertical chop and horizontal chop, what happens? You're going to remove OVD. And what is holding back the iris and keeping it stable to prevent IFIS? The OVD. And so if you utilize less vacuum around the pupillary edge, you're going to have more stable iris because the OVD is acting like a sandbag to push the iris back and keeping it from becoming floppy. And so with mechanical fracturing techniques, double chop and cross chop, you'll see a beautiful illustration of how I'm able to disassemble the lens using purely mechanical fracturing forces and then pulling pieces up out of the bag with the chopper. And by doing it this way, you utilize less ultrasonic energy and vacuum. In particular, vacuum, when you're dealing with IFIS, is so important so you don't remove those sandbags which are keeping the pupil stable. So I use a corneal mark, which will help me to center and size the rhexis and make my paracentesis incision first on the right side and then the left side, making sure I'm parallel to the iris plane, which creates a nice corneal shelf, which will allow me to achieve a self-sealing incision. This is intracameral lidocaine and then some intracameral epinephrine. You can see the billowing of the pupil as I use the epinephrine. This is dispersive viscoelastic, which will inflate the anterior chamber, coat the corneal endothelium, but you can also see there's some viscodilation as well. And this is the triplanar corneal incision. I make a vertical groove, place the blade into the deep part of the groove, tunnel, and then enter. These are the sharp tip Haldey-Perkar forceps. I go in sideways, go vertical now, puncture the center, pull towards me. And again, these forceps also act like a cystotome. Grab the right side of the tear, and I make sure that tear radius is going to be what I want to give me a proper size and centration for the rhexis. I go around circumferentially and grabbing and re-grabbing. Again, nice thin profile, reduced OVD egress, and excellent control. And you can see how widely the forceps teeth open. This is the capsulorhexis hydrodissection technique. I place a cannula under the rhexis edge contra-incisionally, point the tip down, get a nice wave, come back up, decompress on the left side, sweep and push BSS along the anterior capsule rim on the left side, and then the same thing on the right side as well. And then very gingerly, I'm just turning the lens right here. Irrigating the surface of the eye, adjusting my sleeve. Lifting the incision with the chopper, going in with irrigation off to minimize Descemet's trauma. Removing the surface epinuclear material. You can see the chopper tip is pointed out towards the periphery. I slide it under the rhexis edge, contra-incisionally, pointing the phaco tip vertically sub-incisionally. Since the peripheral lens is soft, I'm able to cut the lens, sandwich the central endonucleus, bringing the instruments together and crushing it. That's double chop, placing the chopper around the right heminucleus, pulling it centrally towards the phaco tip, and that is cross chop. Using some vacuum to grab that first quadrant up with some vacuum, lifting it up, and then fracturing the lens. So you can see here again in half speed, I'm leading off with the tip, sliding it underneath the rhexis edge, turning it vertically, turning the phaco tip vertically sub-incision. You can see that the peripheral lens in the epinuclear area, since it's soft, I'm able to embed the instruments into the lens material, and then I'm able to bring the instruments together and crush it for horizontal forces. Again, I'm crushing the lens from either side, pronating my fingers again, and then going underneath the right heminucleus, sliding it under the rhexis edge out to the equator, turning it vertically, hooking the peripheral lens and pulling it centrally toward the phaco tip, and that fractures the lens against the phaco tip, and that is the phaco tip is acting like a chopping block or a cutting board in this instance. Again, using some vacuum to grab that first quadrant up. You can see I'm using the chopper to help support and protect the iris to make sure the pupil doesn't come down in that area. Crushing the lens between the instruments. So this is a very important concept here. As I fracture the lens, you will see that I don't use any vacuum with the phaco tip, and that's very important. You don't want to use ultrasonic energy or vacuum, in particular vacuum, when you're chopping the lens with the phaco tip. Because remember, you don't need to use vacuum when you're chopping the lens. And if you're using vacuum and the pupil is so small, you might grab the iris, which is not good. And you can see this iris is quite floppy here, as I'm showing in this case. And, wrong move here, and you're going to grab the pupillary edge. And then now you're going to have a really tough IFIS situation here. And so that's the point. The phaco tip is acting like an irrigating chopper, okay? The phaco tip is acting like an irrigating chopper. And, it's not really just a chopper. In these instances, it's actually like the chopping block, as I've shown with the cross chop. And so it's an issue of just knowing how to position the phaco tip in apposition to the chopper for the mechanical fracturing force. You just want opposing forces on either side of the lens and then crush the lens. And again, you're using irrigation only, so this is really an irrigating chopper. That's how the phaco tip is functioning, as an irrigating chopper. You're not utilizing vacuum while you're chopping the lens, but once you're ready to eat the lens piece, you go to the central safe zone, you mash the piece between the instruments some more, and then you carefully pulse with the foot pedal and remove the lens pieces. So that's the key. You're only emulsifying the lens when you're in the central safe zone. You're not utilizing vacuum when you're in the active chopping mode of breaking down that lens piece. So I take the chopper out, push BSS in. You saw how very carefully turned off irrigation before I came out with the phaco tip in order to make sure I don't get iris to the wound. So I decompressed the chamber before I came out, and then now I start the INA, starting sub-incisionally. So again, when you come out with the phaco tip or the INA, try to deactivate irrigation. You don't want to have a really pressurized eye and then yank the instrument out, and then it's going to cause the iris to come out to the wound as well. You can see how sticky this cortical material was, and that was the reason why it was a little bit stubborn to turn when I tried to turn the lens. Switch to polish mode, polishing underneath the rhexis edge. Again, the pupil is small, but because I'm on polish mode, which is a low flow setting, I can confidently polish underneath the rhexis edge without worrying about grabbing the bag and causing any trauma to the zonules. You see I'm polishing the posterior capsule in the subincisional area. Oftentimes there is some wispy lens material. You can see it right there stuck on the posterior capsule in the subincisional area, and that is that wispy cortical material which is still incarcerated in the subincisional space. Again, in front of me, I'm able to polish into the capsule fornix pretty confidently and easily, but in that subincisional area, it's a little bit more tricky. So I'm using the polymer tip to carefully peel off that adherent lens material, cortical material, off the posterior capsule in that subincisional area. And by doing it this way, I'm able to loosen it up some more. So when it's time to actually remove from the anterior side, it's going to come off more cleanly here. So doing some more polishing, removing the lens epithelial cells. Again, this is a blind maneuver, but because of the polymer tip in the low flow setting, this is very safe. Because the pupil is so small, rather than pulsing with the BSS in the subincisional area, since I can't see the rhexis edge, I go ahead straight to the cohesive viscoelastic, and then I'm using the sweep to sweep in the subincisional area. And now you can see that I'm able to pull out that subincisional cortical material. Again, it's very fine, wispy material, very annoying. I do think that this can be the source for late lens proliferation. And so you want to make sure you get all that stuff out. Push some more viscoelastic to fill the bag. And you see I'm able to turn the eye away from me. I can see the contra-incisional capsulorhexis edge, and I'm able to slide the lens implant underneath the rhexis edge Go in with irrigation off, activating irrigation, making sure the haptics are off the optic, rotating the lens 90 degrees, tilting it, getting underneath the lens, removing all the viscoelastic from within the bag. And then I'm going to use a multiman to make sure that both haptics are indeed in the bag. Remember, unless you see it like this, you can't know for sure. Of course, you know my concept of tilting the lens. If you see the lens is tilted like that and it goes into the capsulorhexis contra-incisionally, you got to believe that the IOL's got to be fully in the bag. If it wasn't, it would try to fight you because the optic might be outside of the bag, but obviously it's not. And so I feel confident that it's in the bag. And plus I use direct visualization with the multiman to make sure both haptics are within the bag as well. Switch to polish mode, polishing underneath the rhexis edge, and then switching to visco mode, removing the viscoelastic from the anterior chamber, and then I'll hydrate my incision. So again, why is mechanical fracturing great for the IFIS situation? Because remember, when you're doing typical standard cataract surgery, you're using a lot of vacuum around the pupillary edge. And if you use a lot of vacuum, you're trying to use it as a sucker to grab the lens pieces, but guess what? You're also going to remove OVD, and those are basically technically like sandbags holding the pupil down. And so if you're trying to grab lens pieces with vacuum, and that's the only way you know how to do it, you're going to be removing the OVD, removing the sandbags, and then IFIS is going crazy. And so you have to have better techniques. Don't have a technique that's going to cause the sandbags to come out. Hook the lens pieces up, use mechanical forces, and only activate high vacuum in the central safe zone when you're ready to emulsify, and you'll be able to conquer the IFIS situation without having iris coming into the wound, coming into your port, and you'll be able to have a very routine and easy surgery. So I hope this was helpful to you, and I thank you for your attention.